All right, welcome back. So today we are going to be furthering our knowledge on standard form, but today we're going to be learning how to rewrite equations, especially in slope-intercept form, back into standard form. This is going to be a little bit of a topic that we really need to pay attention for. Really need to make sure we are taking some notes, and this video is going to go along with some of the questions that you are going to see in your practice worksheet. So, without further ado, let's begin. Remember, standard form is ax plus by is equal to c, where a, b, and c are whole numbers. So if we look at problem number 1, we are in slope-intercept form, y equals negative 3x plus 9. Our goal is to create an equation that's in standard form. That looks like a number times x plus a number times y is equal to c. If we're in slope-intercept form, this is not standard form, but we can easily manipulate this to turn it into standard form. Notice that in standard form, our x term is on the same side as our y term. Let me actually change colors for you real quick. If we look at our equation, our x term is not on the same side of that equal sign as our y term. So we have to move our x term over to the other side. And we're going to be using the same general ideas that we have been using with moving and combining like terms on both sides of the equal sign. For example, if we had 2x minus 5 was equal to 9. If we want to isolate that 2x, well, we have to move that negative 5. So we perform the inverse operation. So we add 5 to both sides. We cancel out on the original side, and we have 2x is now equal to 9 plus 5. And we know we can simplify this. 9 plus 5 gives us 14. And we can go ahead and solve for x. We're going to be using the same general idea in moving terms that have different variables. If we want to move that negative 3x in our equation over to the other side, well, it's a negative 3x, so we're going to add 3x to both sides. And notice this negative 3x and positive 3x cancel out. So we end up with 3x plus y is equal to 9. And this is our final answer. Notice this is in standard form. Ax plus by is equal to c. We cannot add 3x plus y. Those are not like terms. So since we cannot add them, we're just trying to rewrite this equation. So again, our goal is to take an already done equation and manipulate it into standard form by having our x and y terms all by themselves together on one side of our equal sign, and any constants, any non-variable terms, any straight up numbers on the other side of our equal sign. So try out the next couple, and we're going to be talking about problem number 4. Problem number 4 is written here for you. We have 2x minus 9 is equal to 9 plus 3. Now, again, we want standard form. Ax plus by is equal to c. So we want to get our x and y on one side, and all of our non-variable terms or numbers on the other side. In this problem, we have numbers that are on the left-hand side of our equal sign, as well as our right-hand side of the equal sign. So we're going to try and move negative 9 over to the other side. That way it's one step closer to getting into standard form. To do that, we add 9 on both sides. Notice where I'm lining up the 9. I'm lining it right underneath the number I'm adding it to. Negative 9 plus 9 cancels out. The left-hand side is 2x. We did not do anything with our y. And we did 3 plus 9, which is positive 12. Now, we're not in standard form just yet. Again, we need to have our x and our y terms on the same side of our equal sign. Right now, our x term is on the left-hand side of the equal sign, and our y term is on the right-hand side of the equal sign, but we need them to be together. Now, the plus 12 is already on the right-hand side. We want to eventually get our number all by itself, hence why it's equal to c. So we're going to try to leave this positive 12, meaning we are going to move y to the other side. This is a positive y. Therefore, we have to subtract y on both sides. Positive y minus y cancels out. And now we have 2x minus y is equal to 12. And that is our final answer because we cannot subtract 2x minus y. We can't do it. They are not like terms. And again, this is in standard form ax plus by is equal to c. Yes, there is a subtraction sign between our x and y term, but technically we are adding negative 1y. So we still are in standard form. But if you were questioning that, that's a good question. Keep on questioning it. All right, let's talk about problem number 7. Let's talk about problem number 7. You're going to notice that this is not in slope-intercept form, and this is not close to being in standard form. So we have to do a bunch of math to get us there. And we can do it. We just have to believe in ourselves. So we always want to simplify the left-hand side of our equal sign and our right-hand side of the equal sign before we start to move things over. Well, we cannot do y plus 6, so that stays the same. But we can distribute the 3 to x minus 1. When we do that, we get 3x minus 3 because we're multiplying. Now we cannot simplify the right-hand side anymore. It's already simplified. So just like we did in the previous problem, we're going to want to move our constants first. We're going to want to move either the 6 or the negative 3. It doesn't necessarily matter, but it's always nice to have your terms not be with the x. It's always good to have your terms not be with your x. Therefore, we're going to add 3 on both sides. If you moved the 6, you will eventually get the same answer, so do not worry. Don't fret. We'll actually do that together on the right-hand side of the screen. We add 3 to both sides. We end up with y plus 9, because 6 plus 3 is 9, is equal to 3x. We need to get our x and y on the same side. We have our whole number of 9 is over on the left-hand side, which means that we're going to have to subtract y on both sides. Positive y minus y cancels out. We're left with 9 is equal to 3x minus y. And that is our answer. We are in standard form. It is technically ax plus by equals c. We just have the order switched where c is equal to ax plus by. Now, I told you that we would do it the other way, where we have y plus 6 is equal to 3x minus 3. Last time we added 3. This time let's subtract 6. When we do that, we end up with y is equal to 3x minus 9. And now we need to move this 3x over to the other side. To do that, it's currently positive, so we're going to subtract. we end up with negative 3x plus y is equal to negative 9. And this technically is our answer. Now, you might be saying, Mr. Q, you said we get the same answer. It is, it's just changed by a factor of negative 1. If I were to multiply every single term by negative 1, we would end up with the same answer on the left-hand side. Negative 3x times negative 1 is positive 3x. Positive y times negative 1 is negative y. And negative 9 multiplied by negative 1 is positive 9. So we end up with the same answer at the very end if we were to continue to go one step further. We will end up with the same answer. If you were to type either of these equations into a graphing calculator, you would end up with the exact same graph. All right, awesome. Let's do one more together. So we're still talking about standard form, ax plus by equals c. Looking at this problem, it looks like it's in slope-intercept form, y equals mx plus b, which is pretty cool. So we're going to be manipulating another slope-intercept equation into standard form. We have our y on the left-hand side of our equal sign. We have our x on the right-hand side. Pardon me, I almost said the left-hand side. I forgot my left and rights. Isn't that cray-cray? We have our y on the left-hand side and our x on the right-hand side. We need them to be together. Now, since we already have that constant of 4, that number of 4, we don't want to touch that because we don't necessarily have to. And since we don't have to, we're going to move our x to the left. Just like Beyonce. To the left, to the left. To the left, to the left. Everything you own in the box to the left. All right, I'll stop, sorry. So we're going to be adding 1/2 x to both sides. I know this for fractions. That's okay. We're going to be just fine. Don't worry. Our x on the right-hand side, we cancel out that term. And we have 1/2 x plus y is equal to 4. Now, we aren't quite done yet. Although we might think we are not quite done yet. I'm going to shift this over and you're going to see why. Remember what standard form is, or we can read what standard form is, where a, b, and c are whole numbers. Right now, we don't have all whole numbers. That a term, the coefficient of x, the number attached to our x, is a fraction, and that's no bueno. So we have to multiply everything by a number that will help clear out that fraction. It's easiest to multiply by the lowest common multiple. When we have multiple fractions, we multiply by the lowest common multiple. Or we keep multiplying by the denominator until it gets canceled out. In this case here, we only have one fraction. So what we are going to do is we're going to multiply everything together by 2. The reason is when we distribute the 2 to all the terms that we see, 2 times 1/2 is going to cancel out and we're going to end up with a whole number. When we have one fraction and we want to manipulate an equation to get rid of the fractions, we call that negating the fractions. We multiply by the denominator. When we multiply, that will eventually cancel out. So we distribute 2 times 1/2. Well, what's half of 2? It's 1. So we have 1x. We distribute the 2 to the y. 2 times y is 2y. And we multiply 4 times 2, which is 8. Technically, since we are big mathematicians here, big brain, we don't normally write 1x. So I'm just going to rewrite as x plus 2y is equal to 8. And the reason we have to multiply every single term is because we need to keep the equation balanced. What we do to one side, we have to do to the other. We cannot pick and choose which terms in our equation we work with. If we were to graph, we need to make sure we have the same overall equation as we did before we performed an operation. Awesome, kiddos. With this, keep on working on the worksheet. Y'all are working super hard. Keep on making yourself proud. If you have any questions, please let us know, and I'll talk to you soon.